Hey everyone, it's Cal from Wise Guys Tutoring, back with another EmSAT video. Today we're going to be doing questions 21 to 25 of the EmSAT Math Sample Test from 2022, which is found online. I'll put the link to the test in the description. However, you should know that every time you click and register, you get a random set of questions. But anyway, they're all good practice, so you should try to do as many as you can. I also offer private and group lessons for the EmSAT, so you can hit me up on Instagram at WiseGuysUAE or by email info@wiseguysUAE.com. And yeah, as usual, I'm going to solve all these questions and try to give you a full understanding. So let's get started. Question 21 says solve this equation, and it's a quadratic equation, y squared minus 3y equals 9. Now, when I say quadratic, it's because the highest power here is a y squared. Okay, so the way that we solve this is simple. I'm going to put a link up there in the top right corner because we have solved these and I have a nice video on it. What you want to do when you're solving quadratics is try to solve it first by getting everybody on one side. So let's say we have y squared minus 3y equals 9. To get everybody on one side, what I'm going to do is use my algebra. This is a plus 9. I'll put minus 9 on both sides. These cancel out. So you're going to get y squared minus 3y minus 9 equals 0. And now it's in what we call the standard form. And the standard form has three distinct coefficients. So multiplier of y squared is called a. This multiplier here is called b. And this constant we call c. Now when you don't see anything here where I put the a, it's actually a number 1. We just don't usually write 1 when it's there. You don't write 1x or something because it doesn't really mean anything. 1x is cumbersome. You can just write x. Just the same as you write y squared instead of 1y squared. So in this case, a is equal to 1, b is equal to negative 3, and c is equal to negative 9. What we're going to do now is use something which looks a little bit scary, and it's called the quadratic formula. So y is going to be equal to, get this, minus b plus minus square root of b squared minus 4ac, all of it divided by 2 times a. So it looks pretty complicated, but once you've used it like 100 times, and then you pretty much get used to it and you kind of memorize this. It's called the quadratic formula, and you can use it anytime to solve a quadratic equation. So this is how you start. First of all, let's do the inside of that root because it looks very, very complicated, right? We call it the discriminant, and usually it's symbolized by delta. So delta is b squared minus 4ac. So I'm just going to substitute everybody in here slowly. Okay, so b squared, that's minus 3 squared. I'm going to leave this minus here. That's the same minus here, right? 4 times a being 1, times c being minus 9. And I want to emphasize that I'm leaving this negative in the middle here. So minus 3 squared is 9. I'm going to put this negative still here. And then I'm going to solve these. 4 times 1 is 4 times negative 9. That's negative 36. So if it's negative 36, that's 9 plus 36, which gives me 45. A very common mistake that people tend to make is they try to multiply all this in one shot, and then they get confused because they'll say, well, I have a minus 4, and then I have the minus 9, so that's 4, and then they lose themselves in the negative. Just leave this negative as long as you can. Calculate 4 times a times c separately, like I have done here. And if it's the double negative, then just make it a positive, and that's all. Okay? So the discriminant here is 45. So I'll go back into my equation here. I'll give myself a little bit of room, and then I'll plug these numbers back in here. Now the reason that you see plus minus is because there are actually two solutions, or usually can have two solutions, right? Square root of b squared minus 4ac over 2a, whereas the second solution will be negative b minus square root of b squared minus 4ac over 2a. Okay, so plus minus, you find one and you find the other separately. Now what happens here, we substitute, you get minus 3. In this case we're doing the plus square root of 45 because we found that under the root there is 45, and we divide this whole thing by 2 times 1. So if you put that in your calculator, you will get 3 plus 3 root 5 over 2. And similarly, what you'll get here is minus square root of 45 over 2 times 1. And if you put that in your calculator, you get 3 minus 3 root 5 over 2, meaning that the correct solution here is A. Okay, this means that there's two solutions to this problem, and I took the liberty of graphing like I usually do just to give you guys an idea. So abracadabra, here you go. So that's what the graph looks like. It's sideways because it's y squared minus 3y equals 9. If it was x, it would have been like a happy face parabola there. But anyway, the values that we have come to find, if you put these in your calculator, you'll find that they are approximately -2, and this one is approximately 5. And that's what you're seeing here. You're seeing it right there and right here. Okay, those are when this equation is equal to 0, when the x value is equal to 0, right? These are the y values when x is equal to 0. So that's it. That's how you solve this quadratic. It's not too difficult. There are a number of ways of solving. Like I said, you can do it by factorization. You can change it to a complete the square vertex form. And you can use this quadratic formula. The thing about the quadratic formula is that it can always be used. As long as you identify A, B, and C when you put it in this format, then you can always use a quadratic formula. Sometimes you'll get a bunch of decimal numbers like right now, and sometimes you get nice clean round numbers, but it always works. Okay? One thing to be said is about the discriminant. In some cases, you might get some combination of A, B, C where this discriminant will be negative. And we know that you cannot take the square root of a negative number. So if you get delta less than 0, then you have to state that there are no solutions, right? That's very important. When delta is negative, that means you have to take the square root of a negative number, which does not make sense, not allowed. And so there are no solutions. If by chance you get that delta is exactly equal to 0, remember delta being b squared minus 4ac. If this is equal to 0, then there is one solution. One solution. Okay? One solution means when you're adding 0 or removing 0, you'll get the same answer. So the plus minus will actually be the same answer. And the way that might look on a graph is it would only touch at one point. It would only touch at one point, right? Instead of touching at 2 points, which is 2 solutions, you would touch at 1 point. If you had no solutions, it could look something like this, where it doesn't touch the axis at all. Again, all of these are in y squared, which you will not normally see. Normally what you'll see is an x squared, minus 3x minus 9, and it would look a little more like this. Okay, with the two solutions being here. But it's the same idea. If you had one solution, it might look like something that touches just at 1 point. And if you have 0 solution, it probably touches at no point at all. Okay, let's move on to question 22. This question says, find an angle between 0 and 360 degrees that is coterminal with 673 degrees. Now, what does coterminal mean? When you're talking about angles, so these circles obviously were drawn by me, they're not on your test, but it's just for demonstration purposes. So when we're drawing an angle, let me just give you a simple example first, okay? Let's say we always start from here. We'll call this the initial side. Okay, the initial side is starting from the positive x-axis. And let's say I have an angle of something like 30 degrees. Okay, so we'll call this angle 30 degrees. And we always, again, we start from this initial side here. And this side over here where the angle ends at 30 degrees, we call this one the terminal side. So initial and terminal, it's where you start and where you end, right? Measuring your angle. So if I want a coterminal angle to this angle, let's call this angle theta. If I want a coterminal angle to theta, I can go the other way. I can start from here, go the other way, and I end up at the same terminal side, right? Co-terminal, meaning we end at the same terminal side. So for example, if this one over here was 30 degrees, like in my example, then this green angle over here would be minus 330 degrees. Now, how did I get that? We know, or we should know, that the full circle is 360 degrees. So if I used 30 over here, then my coterminal angle will be theta minus 360 degrees. If I'm going the other way to complete the circle, that means this 30 degrees and 330 degrees together, they make 360 degrees. The reason I put a negative is, like I told you, normally we start from the positive x-axis and we're going counterclockwise. So for me to go clockwise, I just put a negative sign on it. So for our example now, let's try our numbers, okay? They say which one is coterminal with 673 degrees? Now 673 degrees, that sounds very, very large, right? Again, we're going to start from over here. This is the initial side. And let's see where 673 gets us. So starting from here, I'm going to go counterclockwise from the positive x-axis. So up to here, I have 360 degrees, right? I've done one full circle. How much is left? Well, 673 minus 360. I have 313 degrees left to complete. So I'm going to keep going. Here's another 90. Here's another 180. Here's another 270. Now from 270, if I want to get to 313, that means I need 43 degrees more. 43 more degrees. So now my terminal side is over here. Right here. That's my terminal side. So this pink angle that you see, that's 673 degrees. It's 360 degrees, and I've added to it 313 degrees more. Okay? Now they're asking me which angle is coterminal, meaning has the same terminal side. So I'm going to take my red color here to make sure you can see it nice and clear. It starts at the same initial side, and it's going to go all around until I reach that same terminal side. Now, as we said, we had done a full circle, 360. How much was this part? That second go around, it was 313 degrees. So for us, the answer here is going to be 313 degrees. Why do I have this third circle, you may ask? Because there are many, infinite in fact, coterminal angles with 673. Let me redraw it, right? This was the initial one, that's 360, and you keep going for about 313 more, and that was the terminal side. But I can have infinite other angles which are coterminal with this one. We've seen this one, which is 313. But what I could have also done is gone the other way. I could have said minus, if I'm at 313 and there's 360 total, then this little slice over here is about 47. It's not about 47, it's exactly 47. 47 degrees. Since I'm going down, I'll call it minus. So minus 47 degrees is also coterminal with 673. I can also have gone a little bit further and done something like this. Let's use dark blue. So you go around this way and you come back here. So that's 360 degrees, full circle, and 47. So 360. So that one is minus, the dark blue one is minus 407 degrees. That's also coterminal. Okay, so you can keep adding 360 degrees or subtracting 360 degrees, and you'll just keep getting infinite coterminal angles. Fortunately for us, it's been made very clear that they want one angle between 0 and 360, and that would be 313. That's how I knew to settle on 313, because they want us to make it between 0 and 360. All right, so there you go. That's coterminal angles. Let's do number 23. 23 says, use the graph below to answer the questions that follow. Select the interval below for which the function is increasing. For a function to increase, this is what we're going to say. We're going to say it's increasing if x2 is bigger than x1, then y2 must be bigger than y1. That's what increasing means, okay? So if it's increasing, that means if your x is, further to the right, then your y should be further up. As in, if I'm taking, for example, this point over here, this point here, we'll call this x1 and we'll call this one x2. So x2 is larger than x1, and this would be called y2, while this one would be called y1. So if y2 is bigger than y1, then yes, this function is increasing. But really, when they give you a graph, you can sort of just look at it and you can tell, okay? If it's going up as it's going to the right, then we say this is increasing. Okay, so let me clear this and let's solve it. Okay, so let's look at these intervals they've given us and let's choose a correct one. We'll start backwards, wink, wink, because, I know that's the answer. So between 3 and 5, what's happening between 3 and 5? So when x is 3, we're over here, and when x is 5, we're over here. So in this section here, we are going down, right? As x is going up, y value is going down. Therefore, this is a decrease. If you look at 5 to 7, between 5 and 7, here they are, 7 is greater than 5, but they're both at y equals 1. Here it is neither increasing nor decreasing. So this one is not increasing either. Between -1 and 1, you find yourself here at x is -1, we're over here. When x is 1, we're over here. This part here, you were at y equals 4, and now you're at y equals 2. So you're actually decreasing. And then this one would be wrong. So the answer, as we were saying, is when x is -5, here we are. When x is -2, you're about there. So from here you can tell that as x is increasing, right? As x is increasing, y is also increasing. So your function is increasing on this interval. In fact, it looks like from -4 to about -3, it's increasing exponentially, and then it goes on to increase linearly as a straight line. But they don't ask that, so we're good with just saying -5 to -2. Okay, let's do number 24. This one says simplify, and they give us two fractions, -5/7 plus -4/7. So the good news is when you're adding, subtracting fractions, all you need is the denominator to be the same. Whenever the denominator is the same, you can keep that denominator and just add the numerators. So I know that -5/7 plus -4/7 is equal to something over 7. So the denominator is going to stay the same when you're adding and subtracting. So up here what I have is -5 plus -4. And in case you're not sure about negative numbers, the way it works is this. When you have positive and positive, this gives you positive. If you have positive negative, this gives you a negative. Negative positive is also a negative. And here's the twist. If you have two negatives, that becomes a positive. Okay, I'll give you some examples here, some simple examples. If you're multiplying something, for example, 2 times 3, that's equal to 6. If you're doing 2 times -3, it's -6. You see, the value doesn't change, only the sign has changed. In this case, if you do -2 times +3, again, you still get a 6, but since one of them is negative, minus. The only time that the negatives become a positive again is if you have two negatives. So this becomes +6. Okay? I tell you this because over here you have two signs in a row. When you have plus, minus, if you're adding a negative, all that means is you are subtracting again. Okay? It's a subtraction. Plus, minus is the same as minus. You see? So -5 -4/7. Now, how do you do -5 -4? This is something that a lot of students find confusing, and I think it's very, very simply illustrated by using a number line. Let's say 0 is here and -5 is over here. Okay, and this is -1, -2, -3, -4. So if I have -5 and I'm subtracting 4, that means I'm becoming smaller. I'm heading over here to the left, not to the right. So I'm going to go to -6, -7, -8, -9. Okay, when you're subtracting, you go to the left. So this is equal to -9/7. Normally you would have to simplify a fraction. That means, for example, if I had 4/8, I would have to divide both of top and bottom by the same thing, which is 4. That would give me 1/2, and this is the simplified version. But with 9 and 7, they don't have any common factors for me to divide by. So it's actually just -9/7, and that's it. So the answer here would be, the third one would be C. Okay. I'll take the chance, as usual, to give you a bit of background here. I want you guys to know they don't teach this really in school, and I feel it's kind of confusing. Sometimes you might see something like this, like -1/2. Sometimes you'll see it in the middle, like this. Okay. Even with the variable, sometimes you'll see 1/2 of x, and sometimes you'll see x/2. These are the same. They are absolutely the same thing, the same meaning. Okay, if the minus is in the middle or the minus is up, you won't really see the minus down. Okay, even if the minus is down, you should put it back up or in the middle. That's just convention. That's just the way that we write stuff. But these are the same. Okay, so I don't want you to worry about where the negative is. I don't want you to worry about where the x is. If it's in the middle or it's in the top, it's the same thing. Okay, 1/2 times x. If you know how to multiply fractions, what you do is you multiply top with top and bottom with bottom. And when you don't have a denominator at the bottom, it's just a 1. It's like an invisible 1, right, that we don't really write. So 1 times x is x, and 2 times 1 is 2. So these are the same, okay? Just in case that ever confused you. All right, let's do the last question. 25 says the vectors 6 and 4 and 8k are perpendicular. Find k. So first of all, what are vectors? Vectors are kind of like arrows, you can say. They are represented by in this form 6, 4. That means 6 is the horizontal, the x direction, while 4 is the vertical. So it's broken down into components. So let me draw one for you. For example, if this was the horizontal component of about 6, and then you have the vertical component of 4. So it's like an arrow, which is vertical, but it's a little bit shorter. I made it to the right because 6 is positive. I made it up because 4 is positive. Now the resultant vector 6, 4 is the head to tail, there you go, sum of these two. That's the vector which we call 6, 4, okay? Normally they designate it with a letter or something like that. We can call it, for example, vector A with a little arrow on top like that. This measures 6, while this one measures 4, okay? This other one, well, we don't know what the vertical component is. We just know that horizontally it's 8 to the right. Okay, now how do we find k? There's a very unique property for vectors which is called the dot product. And the way that the dot product works, so as we did before, let me call this one A and let me call this one B. And the dot product is calculated like this. You would say A dot B. It's also called the scalar product. The way it's done is this. You take AX, so the horizontal component, multiplied by the horizontal component of B, and you add it to the Y component product. Okay? So this is AX, and this is AY. This is BX, and K would be BY. This is called the dot product or scalar product. And when two vectors are perpendicular, okay, the scalar product or the dot product is equal to 0. Okay? So that's how we're going to solve this. Knowing this property, this dot product should be equal to 0. Right? So if it's equal to 0, AX is 6 and BX is 8. AY is 4 and BY is K. Knowing this, I'll be able to solve for K. So 0 is equal to 48 plus 4K, meaning minus 48 on both sides to get rid of him. So now I have negative 48 equals 4 times K. I will divide both sides by 4, and I'll end up with K is equal to negative 12. And that'll be the answer. I have no idea why they put degrees. There is no degrees here. It's just minus 12. So that's the dot product. That's how you do it. And that's how you will determine if something is perpendicular. That means the angle between them is 90. That means the dot product will be equal to 0. There is another equation for the dot product. It can be equal to the components like this. And another prevalent form that you might see is the magnitude of A. That means the length of A times the magnitude of B. Again, meaning the length of B, times cosine of the angle between them. Now, if we're talking about perpendicular vectors, right? Perpendicular means 90 degrees between them. And we know that cosine of 90 is 0. So if two vectors are perpendicular, that means cosine 90 is in there. And if 0 is in there, that means the whole thing goes to 0, right? Because anything times 0 is 0. So if you have 90 degrees between them, in other words, if they are perpendicular, then the dot product is always going to be 0. Okay? That's it. That's it for this video. I feel these questions were a little bit simpler than the previous 5, which had a lot of calculus and things like that. If you do have any questions, please do let me know in the comments. Any suggestions or anything you really want to work on, just let me know down there. Please like the video and subscribe to the channel. I'm going to keep making as much as I can for you guys. And again, if you want any EmSAT private or group lessons, just hit me up on Instagram at WiseGuysUAE. Look forward to talking to you guys, and I'll see you in the next video. Thank you.